So K-map simplification method is used to minimize the Boolean expression. So it is the method, it is a map method which gives us a systematic approach for simplifying a Boolean expression. So this map method is first proposed by Waite and modified by Karnaugh. So hence it is called as Waite's diagram or Karnaugh map, shortly known as K-map. So this K-map is usually used in all the logic circuits to minimize the Boolean expressions. So in the K-map, there are many different types of K-maps: one variable, two variable, three variable, and four variable K-maps. And higher order variable K-map also available. So 1, 2, 3, and 4 variable K-maps are the most commonly used K-maps. So the basis of this method is a graphical chart which is known as Karnaugh map. It consists of boxes called as cells. So each box in the K-map are called as cell. Each cell represents one of the 2 power n possible products that can be formed from n variables. Thus, a 2 variable K-map contains 2 power 2, which is equal to 4 number of cells. 3 variable K-map contain 2 power 3, 8 cells, and 2 power 4 variable K-map contains 2 power 4, which is equal to 16 number of cells in it. So the given figure denotes the 1 variable, 2 variable, and 3 variable K-map. So in 1 variable K-map, we have 2 cells which is denoted by a single variable A. So A have 2 possibilities, 0 or 1. In a 2 variable K-map, there are 4 number of cells. So, but since it is 2 variable, we have 2 variables here, A and B. So for each variable, there are 2 possibilities, 0 and 1. And likewise for B variable, there are 2 possibilities, 0 and 1. So always 0 is denoted as a complement. So 0 is denoted as A bar or B bar, and 1 is denoted as A or B. And in 3 variable K-map, there are 8 number of cells. 2 power 3 is equal to 8. So there are 8 number of in a 4 variable K-map, there are 16 number of cells. 2 power 4 is equal to 16. So we have 16 number of cells. So since it is 4 variable K-map, we have 4 variables A, B, C, and D. So each of the variable has 2 different possibilities. So we have uh, almost 16 different combinations to be represented. So the representation is given. So here M0 and M1 represent the min terms, 0th min term and first min term. In 2 variable K-map, in 1 variable K-map, we have only 2 min terms, M0 and M1. In 2 variable K-map, there are 4 min terms, M0, M1, M2 and M3. So these are the order of the min terms that are to be arranged inside the K-map. In 3 variable, we have 8 min terms from starting from M0 and ending with M7. So the order is M0, M1, M3, M2, and then the next row M4, M5, M7, and M6. So the elements has to be filled in the specified order. So the min terms are given below according to the cell number 0, 1, 2, 3. Likewise for 3 variable K-map 0, 1, 3, 2, 4, 5, 7, 6. For 4 variable K-map, the order of the min terms are given. So M0, M1, M3, M2. The next row M4, M5, M7, M6. Then you have to leave one row and then go to the last row M8, M9, M11, M10. Then from the third row M12, 13, M15, M14. So in this order, the element has to be filled, the min terms has to be entered inside the cell. So another form of representation is POS. So the previous form is called as SOP representation. So next comes the POS representation. So in POS, we have max terms. So opposite to that of min terms. So in max terms, we have capital M0 and M1 for a one variable K map. Similarly, the order is same, but min terms and max terms will differ. Similarly, for four variable K map also, the order is same. We have to enter the max terms in the given order for POS representation. So plotting a K map. So what is cell? The cell is the smallest unit of a K map corresponding to one line of a truth table. The input variable are the cell's coordinates and output variable is the cell contents. So the input variables are has to be written in the axis of the K map and output variable is written inside the boxes. So here a truth table is given. Inputs are A, B and C. So we have to draw a three variable K map. The inputs A, B and C should be specified in the coordinates. So A is specified in the lower coordinate and B, C are specified in the upper coordinate. The output Y is written in the inside the cells in the specified order for three variable K map M0, M1, M3, M2, M4, M5, M7, M6. So in this order, the output Y is written inside the K map. Similarly, for four variable, we have four variables here. A, B and C, D are written across the coordinates and Y values are written inside the cells. So the order that is specified for four variable K map is satisfied here. The element should be written in the specified order. So representing standard SOP on the K map. So we have a Boolean expression y is equal to some expression is given. We have to plot that expression on the K map. So since it involves only three variables A, B and C, we can draw a three variable K map. So the terms which contain in the y equation should come as the output of those terms will be 1. So A, B, C bar. Okay. So first row is, second row is A and B, C bar will come in the second row, fourth column. So that element is mentioned as 1. The next A, B, C. So second row, third column, the output is 1. A bar, B bar, C. First row, first column, first row and second column, the output is 1. Only for these three min terms, the output are 1. For the remaining min terms, the output is 0. So in this order, the elements are mapped inside the K map. Similarly, for four variable K map, in the equation that involves four variables A, B, C and D. So likewise, seeing the expression, the corresponding terms, the output should be mentioned as 1. The remaining term should be mentioned as 0. So in this way, the elements has to be filled inside the K map. So here directly the min terms are given. The first one 1, 4, 6, 7. So these elements, the output is 1, remaining 0. Similarly, for the next problem, the min terms are given. Only for those min terms, the output is 1. The corresponding places should be written as 1. The remaining should be 0. So in POS, the given expression, the output is 0 for the given terms and for the remaining terms, the output is 1. So here max terms are given. So 1, 4, 6, 9, 11. These are the max terms. Only in those position, the output is mentioned as 0. Remaining terms are represented as 1 since it is a POS form. The next one is grouping cells for simplification. So first we have entered the K map and we have entered the contents in the K map. The next one is grouping the elements that we have entered So this is called as grouping. This grouping is nothing but the combining terms in adjacent cells. Two cells are said to be adjacent if they conform the single change rule. That is, there is only one variable difference between the coordinates of two cells. So grouping has to be done for the simplification of the Boolean expression. So this grouping involves different types, that is quad, octet, pair and single. So these are the four methods of grouping the Boolean expressions. Thank you.